liftoff of Falcon 9.
Good evening from SpaceX headquarters in Hawthorne, California. It is August 6th at 10:04 p.m. here and 1:04 a.m. local time at Slick 40 in Cape Canaveral, Florida. You are looking at a live view of the Falcon 9 awaiting its 1:18 a.m. Eastern Time launch. My name is Lauren Lyons, and I'm an engineer in our Flight Reliability Department here at SpaceX, and I am pleased to welcome you to tonight's webcast of the Merah Putih satellite launch for our customer, PT Telkom Indonesia. Now, tonight's launch is the 15th by SpaceX this year, and is a reflight of our first ever Block 5 rocket. We're going to attempt recovery of the first stage on our drone ship, Of Course I Still Love You, which is situated 635 kilometers off the coast of Florida. If we're successful today, this is going to be our 28th successful recovery of a Stage 1 booster. Tonight's launch window is 2 hours long, but we are shooting for the very top of that window, and we are currently at just under T-minus 13 minutes and counting. So you're looking at a live view of the Falcon on pad 40. Falcon 9 is a 2-stage rocket standing 70 meters tall, which is greater than the wingspan of a 747 aircraft. The first stage, which is the bottom 2/3 of the vehicle, is our booster stage, and it, along with the 9 Merlin engines on the bottom of it, does the bulk of the work to get Falcon 9 off the ground and up into the thinner parts of Earth's atmosphere. Now, you can kind of see it from this image here, but do you see all that dark soot that's on the rocket? That's because this booster has been flown before. This is the first ever Block 5 booster, and it supported the Bangabandhu Satellite-1 mission just over 12 weeks ago. The Block 5 upgrades allow Falcon 9 to be reused 10 times or more with minimal refurbishment between each launch. And today, we will attempt this booster's second recovery. Now, right on top of Stage 1 is our second stage, which has with it a single Merlin vacuum or MVAC engine. This is the engine that ignites after the first stage separates. The second stage is what will carry the Merah Putih satellite to its Geostationary Transfer Orbit. Now, on the very top of the rocket, as you can see here, this conical structure, this is the payload fairing, and safely encapsulated within it, the Merah Putih satellite. This is what protects the payload from aerothermal loads and heating and contamination upon ascent. However, once you reach that vacuum of space, we're going to jettison the fairing as Stage 2 continues its journey to orbit. Note that we will not be attempting recovery of the fairing today, as the recovery vessel, Mr. Stephen, is out on the West Coast. Now, this large white truss structure that you see on the back of the rocket, this is the Transporter Erector, or TE, as you may hear it called out on the net. We use it to roll the rocket out to the pad from the hangar and to raise it to its vertical launch position. The TE also routes the vehicle's fluids, power, AC systems, and telemetry umbilicals from the ground systems to the rocket and satellite up until Falcon 9 goes on internal power and clears the pad. At liftoff, the TE will retract, clearing the way for Falcon 9's ascent. Falcon 9 rolled to the pad with the Merah Putih payload early Monday morning and went vertical roughly at 12:30 p.m. local time. The launch director conducted the go-no-go poll for pop load at T-minus 1 hour, and we began loading propellants at T-minus 35 minutes. Speaking of those propellants, Falcon 9 is a bipropellant rocket. It uses kerosene, or RP1, for its fuel, and liquid oxygen as its oxidizer. And to complete that fire triangle, Falcon 9 uses TTEB as its igniter fluid, which we'll see at T0 via that telltale green spark that you'll see right before the rocket takes off. So fuel load is currently full on stage 1 and stage 2. Liquid oxygen load is about 90% complete on stage 1 and just over halfway complete on stage 2. Now once both tanks are full, those stages will continue to be topped off with propellants until T-minus 2 minutes in order to keep those temperatures as cold as possible. Low temperatures lead to a denser propellant, which allows us to fit even more propellant into the tanks of the rocket. In addition to the RP-1 and liquid oxygen aboard, Falcon 9 also uses helium in order to keep the tanks pressurized in flight and the propellant flowing correctly into the engines to prevent any air bubbles or gases from entering the engines as the propellants deplete. Helium load began before the webcast went live today, but it's going to continue to be topped off until about a minute and a half before launch. Additionally, engine chill procedures have begun, and this is where we open up those pre-valves between the first stage prop tanks and the 9 Merlin engines. What this does is it allows a little bit of that cold liquid oxygen to flow into the turbopumps, bringing them down to a temperature close to that of the super chill propellant that will soon be flowing through the engines at liftoff. The vehicle is healthy right now. The Falcon 9 team is tracking no issues. The payload went on internal power at T-minus 15 minutes, and we're hearing the payload is healthy, and the weather is looking really good for an on-time launch today. The last weather balloon that was launched is showing that everything is within wind limits. We're not violating any of the cloud rules, and things are looking really good for an on-time launch today. Additionally, the range remains green for launch, and as of right now, all systems are go. The Merah Putih satellite being launched on today's Falcon 9 is for our customer PT Telkom Indonesia, the largest telecommunications and network provider in the country. Merah Putih, which translated in Indonesian to red and white, is a reference to the colors of the Indonesian national flag. This satellite will play an important role in enhancing telephone and internet service for Indonesia's 17,000 islands, particularly for remote areas as well as other parts of South and Southeast Asia. The satellite is built by satellite manufacturer SSL and has 60 C-band transponders. It's going to be placed at 108 degrees east in geostationary orbit. The satellite will expand the company's coverage to new markets and complement other technologies such as fiber and submarine cable. PT Telkom Indonesia has put together a video about their operations that we'll show you right now.
Indonesia. We cover thousands of islands using the latest technologies to provide the best services from the smallest villages to the largest cities. For many decades, we have walked hand in hand with the nation, bringing change for a better life. Telkom Indonesia, a byword for Indonesian innovation. The only company dually listed on both the Indonesian and New York stock exchanges. As one of the best public companies in Indonesia, Telkom Indonesia has a vision, mission and strategic objectives to grow through continual improvement. Telkom Indonesia offers business and product portfolios tailored to suit the needs and lifestyles of its consumers. Mobile services, fixed services, consumer digital, enterprise digital, interconnection and international traffic, and network infrastructure. Telkom's Digital Times services, supported by the synergy of business entities, with state-of-the-art technology and the widest coverage. In order to realize its vision, mission, and strategic objectives, Telkom Indonesia is focused on increasing business growth through its mobile cellular business, as shown by its broadband backbone network from Sabang to Merauke. and the establishment of business services in Singapore, Hong Kong, Timor-Leste, Australia, Malaysia, Macau, Taiwan, the USA, Myanmar, and the Kingdom of Saudi Arabia. 3P is a concept for Telkom in implementing corporate social responsibility. Planet, creating a digital environment. People, creating a digital society through ICT training. And profit, creating a digital economy. Telkom Indonesia has won recognition and numerous awards for its performance at local, regional, and international levels. Telkom Indonesia is conquering digital technologies in the air, on land, and at sea, and is set to become the king of digital.
We are currently 3 minutes and 35 seconds away from liftoff, and Falcon 9 is moving into the final stages of the countdown. The first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. The first stage should complete its loading at T-minus 3 minutes, and the second stage will finish its topping off at T-minus 2 minutes. At the T-minus 60-second mark, listen in closely for the announcement that Falcon 9 is in startup, which means that the rocket's autonomous internal flight computers have taken over the launch countdown. The Merah Putih payload continues to be healthy. The Falcon 9 team is tracking no issues on the rocket. The weather is looking beautiful, and the range is green for launch. So as we near that T0 mark, let's listen in to the countdown net.
Stage 2 LOX load is closed out. Falcon 9 is on internal power. Falcon 9 is in startup. Go for launch.
Minus 15 seconds.
Falcon 9 is at flight pressure.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
vehicle pitching downrange.
Stage 1 propulsion still on.
Falcon 9 is supersonic.
We are 1 minute and 7 seconds into flight, and as you can see, Falcon 9 has successfully lifted off. Coming up next, you'll hear max Q.
Vehicle is experiencing maximum dynamic pressure.
And as you just heard, the vehicle is experiencing maximum dynamic pressure. That's the point at which the stresses on the Falcon 9 are highest than they are at any other point during the flight.
Back engine chill.
Everything is looking nominal right now. Now coming up, you're going to have 3 events happening in rapid succession. The first is MECO, which stands for Main Engine Cutoff. That is where all 9 of the Falcon 9 first stage engines will shut down. That'll be followed by stage separation. That's where stage 1 will separate from stage 2. And then we'll have SES1, or second engine start 1. That is where that MVAC engine, that Merlin vacuum engine on stage 2 is going to ignite and carry stage 2 onto orbit. We hear that MVAC chill is looking good. That's where we bleed a little bit of that super cold liquid oxygen into the engine.
Ascent shutdown. MECO.
Stage separation confirmed.
And as you can hear by the applause and see on your screen, we've had a successful stage separation and ignition of that second stage MVAC engine. Now coming up in about 25 seconds, we're going to have fairing deploy. So those fairing halves are going to split away from stage 2 and make their way down to Earth. And stage 2 will continue on with the Merah Putih satellite onto its parking orbit. MVAC D had a really solid startup, and all of the temperatures are looking really good. The burn is going nominally right now.
Separation confirmed.
And as you just saw, we just had a successful separation of that fairing. Once we get into the vacuum of space, we don't need it anymore, so we get rid of that extra mass.
Second stage is following a nominal trajectory.
And as you just heard, second stage is on a nominal trajectory. Now, there are going to be 2 stage 2 burns for this mission. The first is this one that is taking the spacecraft to its parking orbit.
Acquisition of signal.
Once it shuts down, it'll coast for about 18 minutes before relighting over the equator to raise Merah Putih to its deployment orbit, the Geostationary Transfer Orbit. Now, while stage 2 is doing its job, stage 1, it's making its way back home down to Earth. Now, it's going to execute 2 burns. The first is the entry burn, which is coming up in about 1 minute and 50 seconds. So the first stage is traveling at roughly 2,300 meters per second. And what this 3-engine burn is going to do is assist gravity in rapidly slowing the stage down. If we didn't do that, it would overheat and it would break up. This slows it down and protects it as it enters the Earth's thicker upper atmosphere. Now, the second of those stage 1 burns is called the landing burn. This is a single engine burn where we light that center engine E9, and it brings the vehicle's velocity down rapidly from about 250 meters per second to about 2 meters per second in order to gently land the rocket on the drone ship. Now, stage 1 landing should occur just a second or 2 following second stage engine cutoff. So there's going to be a lot happening all at once, so watch closely for this next series of events. Now we're about 50 seconds away from that entry burn, but just note that once we recover this booster, we plan to fly it a third time later this year. As mentioned before, this is possible due to those Block 5 upgrades, which brings SpaceX closer to its goal of full and rapid rocket reusability. Right, we're getting close to that entry burn right now. On the right, MVAC continues to burn nominally, and there we go. That entry burn has started.
Stage 1 of the entry burn. Stage 1 entry shutdown.
It is.
Stage 2 continues to follow a nominal trajectory.
So what you just heard there, stage 1 entry burn has concluded. Stage 2 is still looking beautifully. We're going to have that landing burn, that last and final burn on stage 1. It's going to begin at about a minute or so. And then, as I mentioned earlier, just a couple seconds after that, we're going to have SECO 1. Stands for Second Engine Cutoff 1.
Stage 1 transonic.
Falcon 9 is in terminal guidance.
So while we may have lost the view of the drone ship, the view of stage 1, we did get the call out that stage 1 is transonic, and it's making its way on down to the drone ship right now. So hopefully we'll get that camera view back.
Stage 1 landing burn.
Landing burn has begun. Let's see what we get. So we lost the video right there, but hopefully we will get that back. Hopefully, but we have heard that we've had a successful second engine cutoff and that stage 2 is in a good orbit. Hopefully we can get a view on that drone ship if everything stabilizes, but if not, we'll give you an update on the status of the first stage once we get it. What we're hearing right now is that stage 2 is in a good orbit. It's in its nominal parking orbit. And so what we're going to do right now is we're going to take a little break. As you can hear, we got it. Awesome. This is the second landing of this booster. Landed successfully on board. Of course, I still love you. It's a great shot right there. Meanwhile, second stage is in a good orbit, as I mentioned before. It's going to continue to coast, and we're going to take a little break here and come back at T+26 minutes for second stage relight and then deployment of the Merah Putih satellite.
Loss of signal Bermuda as expected. Phone acquisition of signal.
Welcome back to the webcast. The second stage engine is about to briefly reignite for its second and final burn to place the satellite in its intended geostationary transfer orbit. SES-2, which will come on at T plus 26 minutes and 22 seconds. It's going to burn over Gabon for about a minute, followed by payload deployment about 4 minutes later. So that burn should be starting in about 15 seconds. And as you just saw, we just had a successful reignition of the second stage Merlin vacuum engine. This burn will continue for another 20 seconds or so. Power is good, the temperatures are looking good, the burn is nominal. Hopefully we'll get that live image, but second engine shutdown 2 should be coming up very shortly.
MVAC shutdown.
And we just had successful shutdown of MVAC. Let's wait to hear to see if we're in a good orbit.
Nominal orbit insertion for payload deployment.
Great, we are in a solid orbit. Now payload deploy will be coming up in just a few minutes here. What we're gonna do is we're gonna take a pause and then come back to see the live deployment of the Merah Putih satellite.
position of the signal, HPK.
Welcome back. We are about to reach the payload deployment phase of today's mission. Should coming up in approximately 50 seconds. Now the payload is mounted to stage 2 on what we refer to as a payload adapter. And after the stage separation signal is sent, there is a spring-loaded band around the base of the satellite. What it'll do is it'll fire and open up, and then there are 4 compression springs inside the payload adapter that will gently push the Merah Putih satellite away from Falcon 9, and that spacecraft will continue on to its final destination in geostationary orbit. So payload separation should be in about 15 seconds. We'll be able to see it live, hopefully. And there you go. You can see the Merah Putih satellite just in front of you with the sun behind it, giving it a nice backlight. And successful separation.
Payload separation confirmed.
As you just heard, payload separation confirmed. You can see it. It's looking good. And with that, that brings Falcon 9's mission to a close today. And of course, that's the end of our webcast. So a great thanks to our customer, PT Telkom Indonesia, for entrusting us with tonight's mission. A thank you to satellite manufacturer SSL, the 45th Space Wing for providing range safety today, and to the FAA for licensing today's launch. We'd also like to thank all of our viewers for tuning into this late night or early morning launch, depending on where you are. And if you are excited about what you've seen here tonight and want to join us on our mission, please visit spacex.com/careers to check out our current list of job postings. You can also follow our website and social media platforms for updates on our next missions and milestones. But until next time, have a good night.